If we look through our practice midterm, we will see there's a part 1 and a part 2. Part 2 starts on problem like 41 or something. There it is, 41. Part 2, calculator. There is a calculator portion of multiple choice on the actual AP exam. There's a calculator portion for the free response part of the exam as well. But you will need to be ready for the calculator portion for your midterm. Now, some things you should notice right away. If you look at 41 and 42, you're not going to use your calculator for these questions. Just because this is a calculator allowed part does not mean you use your calculator for every question. Write that down on your notes somewhere. Calculator part does not mean every question you will use your calculator. "41, 42, you're not going to use it. 43, you're not going to use it. 44, you're not going to use it. But then you get to 45, 46, 47, you'll use it. Nope, 48 not. 49, nope. 50 maybe. 51, yep. 52, yep. 53, nope. 54, nope. 55, nope. 56, yep. It ends up being about like a third of the questions on the calculator part you will actually use your calculator. Okay? Now, because it's a calculator question, what's very important is that you cannot forget about calculus. Okay? Calculator doesn't mean, oh, I have my calculator, I should be able to see my answers. You still need to understand calculus to be able to do these calculator questions. This is our last lesson before we take the midterm. It's about calculator usage to prepare us for the calculator questions. Your homework will be like practice, multiple choice calculator questions, and that will prepare you for your quiz next class, which will be like actual calculator questions that you will see similar questions to on your midterm, okay? And there really are 3 things, maybe 3.5, 4 things that you need to be able to do using your calculator. Okay, so we're taking notes. Ready? Go to your notes packet. First thing, you need to be able to find a tangent slope to a point at any location. Example, take a derivative of this function. You do not want to try to take this derivative. There are some functions where it's like, don't take that derivative. You have a product of 3 things, 2 of which has chains. You don't know a product rule for 3 things, you know a product rule of 2 things, which means you'd have to use like the product rule twice. It's like gross. Instead, your calculator will be able to do this. There are 2 ways to do your calculator. I'll go through them quickly. So please write down notes and then make sure you try it with your calculator as well. 1 is to use y equals. You will graph the function and then you'll go into second calc dy dx. You will make sure you type in your x equals your number. The second is on your home screen. You will press math and derive. You will either physically type in what you see here. If you have a newer operating system, it's literally just make sure it looks like that. Or you will be typing in and derive your function. You will use a comma with respect to x and a comma with the number that you'd like to take the derivative of. Let you copy that down, and then we will do both fairly quickly, so please pay attention. If for some reason it doesn't work for you, you'll have to go back and just try it again at another time. But don't get caught up on one of these things because you might have just accidentally typed something in wrong. Okay, we got to keep moving. So, in y equals, first things first. Notice we have a trig function. You got to write down this. Your calculator needs to be in radian mode at all times for this course. You will never be in degree mode ever in this course. So make sure you go into your mode and you are in radian mode. We are in radian mode. We are ready to now graph sine of x to the fourth times e to the x squared times x. We'll talk more about this in the future, but you can always go back to Zoom standard so that you have the standard 10 by 10 window. Now this looks crazy, but it doesn't really matter. We'll come back to this. You can go to second calc. You notice dy dx. Calc is above trace. Second calc pops up a calculate button. You go down to 6, or you type in 6. You will then type in your x coordinate. X equals 1. And you will get your slope, 12.736. You will only need to answer your questions with decimals, and you will only need to round to 3 decimal places or truncate after 3 decimal places. I prefer to truncate. Now, a lot of people are like, what the heck is truncating? Truncating means that for the AP exam, they will allow you to write the first 3 decimal places and then leave off the rest. So I don't have to worry about rounding up or rounding down. This is truncated after 3 decimal places. It will allow it. It's what they do in China, and the College Board is trying to get more people in China to take their tests so they can make more money. Okay? So just write 3 decimal places, leave the rest off. Isn't that great? I think it's very easy to do, especially when you have to round up and you get zeros and then you go around the next number and stuff like that. Great. Okay, so that's one way. The other way, please go into your home screen. Second quit to go to your home screen. You'll go to Math and Derive. If you have a newer calculator, it will just pop up as ddx, and you will have to type in x, and then you'll type in the function, and then where it says x equals, you put in 1. If you have an older calculator, you go to Math and Derive, which is 8. Math 8. It pops up as and derive. You will then type in the function. You're going to put a comma to say with respect to x, and then you're going to put a comma, and you're going to put the number. So, the older operating system, you'll do sine x to the fourth times e to the x squared times x. Make sure if you have any open parentheses, those are closed. You will then press a comma with respect to x. And then you'll press another comma to say when x equals 1. So take the derivative of this with respect to x. When x is 1, you should get 12.736, just like we did. You do not have to use my calculators. If you have your own calculator, I advise you bring it to the AP exam. Now, I'd like us to be careful. Please, without a calculator, tell me what is the derivative of the log x function when x is 2? Don't use your calculator. Tell me what the derivative of log x is when x is 2. Everybody, discuss with your neighbors the derivative of log x when x is 2. What's the tangent slope generator for log x? Plug in 2. We get 1 over x, we plug in 2, you get 1/2. Great. Okay, confirm that we get a slope of 1/2 using your calculator. Please find the derivative of log x at x equals 2 with your calculator. We got some extra decimals going on. When you type that into your calculator, you get 0.50000000412 or something like that. Well, who's right? Mr. Alphasar, are you right? Is this slope exactly 1/2, or is your calculator right? Is the slope close to 1/2, but not exactly 1/2? No! No! You're right. You should have confidence in yourself because you're smarter than the calculator. The calculator has more computational power, but you know about the existence of a tangent slope generator. You know about the f prime function that generates exact tangent slopes for an f function. Exact tangent slopes. 1/2 is the exact answer, but your calculator is misleading you. Why? Because your calculator isn't smart. Your calculator can do quick computations, okay? Something that we can't do, it can do. Your calculator doesn't know about the existence of f prime. What do you think your calculator does if it doesn't know that the derivative of log x is 1 over x when it finds 0.500000412? Remind your neighbors what we did the first time we calculated a tangent slope. What do we do? Yes, you do. You just said it.
With 2 points, and then try to find one.
What 2 points should we use? Really close ones. Like what type of values? Like how close? Right. This is what your calculator does. Your calculator does not know the tangent slope generator for log x is 1 over x. Your calculator says, you know what I can do? I can plug in 2.001 into the log function. I could plug in 1.999 into the log function. And then I could divide that by the change in my x's, and it uses the slope formula. Just use 2 zeros, but then I use 3 nines. Now, it is because in this class, most of our slopes, if you end up close to like a rounded number, look at that. Look at that. It's like the exact same number that they produce, right? That's where this number came from. They just got really, really close, but they weren't perfect. You can go ahead and assume that your actual answer is exactly 0.5, okay? So careful, your calculator approximates. It goes with solving equations. If you're asked to solve an equation, you could solve any equation by graphing. You do not have to try to solve all of our equations by hand because some of them are impossible to solve by hand. Does anybody know how you solve an equation like this using your calculator? Did you guys learn this in past math classes, how to solve equations with like non-whole answers that are not quadratics and you can't use a fancy quadratic formula? Nobody taught you this? It's a simple idea. Intersections. Your calculator can find an intersection easily. You can graph y equals the left side and y equals the right side. And your calculator can find when the two graphs cross. When the two graphs cross are when the left side for a specific x value will equal the right side for a specific x value. It's very simple, this concept. Which x will produce a y that gives me this y of 4? It doesn't have to be a number, too. This could be another function. And we will still see which x's will have the y's be the same. So let's go ahead and find the solution to this equation. Y equals x to the 2/3. Make sure if you're typing in 2/3 into a power using parentheses, if you have an older calculator, plus x minus 3, y equals 4. If I find my intersection, now some of you might forget how to find intersections. Again, we go back to second calc, but then we find the intersect button. Second calc. Intersect is 5. Now, if you have more than one intersection, it's very important to scroll over to the intersection you're looking for. I can see my intersections right there. You will press enter to confirm your first curve, the second curve. You will press enter. If you only have two curves that are graphed, two equations that are graphed, you don't have to worry about this. You can just blindly press enter, enter, enter. But if you have like 3 equations that you're graphing, you could find specific intersections between 2 of the 3. Okay, so that's what it means by first curve and second curve. It's like which 2 of the 3 are you looking for? Here we only have 2. And the last thing is guess. Make sure you press enter until it says intersection. And this is my solution, 4.339. But again, it does not have to be a number. We could literally say, you know, maybe the right side was x squared minus 4. And all of a sudden, we can find these solutions. A seemingly even more difficult one. You just find both intersections. There are 2 solutions. Second calc, intersect, pop over to the one on the left, enter, enter, enter. -1 actually works. That's pretty cool. You wouldn't have been able to find that by hand except if you were just guessing and checking. But -1 works. Second calc, intersect. Maybe the other one's a whole number. Let's find out. Nope. 2.2177361. Okay? So you can solve any equation using your calculator. This goes back to like in Algebra 1. You could have been taught this and you would have been able to solve anything. Okay? Cool. Last thing you need to be able to do is adjust windows. Sometimes, if you look at the entire graph, like our first graph that we were looking at, it's very messy. But you don't need to look at everything. You just only need to look at a specific part. The question here is how many times does this graph cross the x-axis? This is not really a calculus question. This is more of a calculator question. Let's just make sure we are comfortable with adjusting our window. All right, so in y equals, you can graph sine of x cubed plus cosine -2x. And I can see it's like, oh gosh, this crosses the x-axis a lot. And if I don't adjust my window, I cannot visually see how many times this crosses between 2 and 2.5. Go to window. You see x min, x max, y min, y max. This is what we are going to adjust. Our x min and max and our y min and max. It shows us like which x's do we start with and end with. Which y's do we start with and end with. Tells you your x's are between 2 and 2.5. 2 has an x min, 2.5 as an x max. Maybe you want to go from like 1.5 to 3. Sure, you could do that. But you could also just start where you start and where you end. Now you graph that, and like, oh, maybe like we're doing too much stuff over here. I'm not exactly sure what's going on. Well, adjust your y's. You don't necessarily need to go all the way down to -10 and 10 if we're just looking at things crossing the x-axis. Why don't you go from -1 to 1? And then when you graph, it's much easier to see that, oh, okay, we do not cross at 2.5. We do not cross at 2. We just cross here and here. There are 2 times, twice. Okay? All right. Now, let's go to the last example. I think the last example here does all 3 of the, you have to be able to do all 3 of those things for this one simple example. Let's see if you guys can do it. E to the tan x minus 2 crosses the x-axis at one point between 0 and 1. What is the slope of the tangent at this point? In your notes, it's the last question. Now, if you ever feel like I need to reset my window, you will go to Zoom Standard. Zoom Z Standard. That puts you back into the -10 to 10 and -10 to 10. But I want to go from 0 to 1. And I want to know when it crosses the x-axis once. So I'm going to change my y's to -1 to 1. That way I can just see better this location. Gosh, crossing the x-axis. How can I find this location? You can do second calc 0. That's one way. But there's also another way to find this location using an intersection. What? Yes. Would we need? We would need, and this is important, a y equals 0. Most of our equations that we're going to be solving, you will have to find zeros. Graphing y equals 0 to find zeros, I think, is more efficient than using second calculate 0. We'll go back and talk about finding maxes and mins as well, but you will need to either understand this left bound, right bound stuff, or figure out how to find the zeros. Now, here's important. You want to just round this to 3 decimal places if this was the final answer. But this is not the final answer. I need to use this. Because I need to use this, do not round until you get a final answer. Okay, I got 0.606119. We will now second calc my dy dx at that point. Now notice my cursor moved a little. It's now at 0.6060606. I don't want that. I want 0.6061119, and I get my answer that I can now round dy dx is 2.960.
There was no answer choice.
And you just wrote it down. Okay. Okay. Now go back to adjusting windows and finding solutions, there are situations where we need to find maxes and mins. Now, if you, let's say, went back to this equation, sine x cubed plus cos negative 2x, and you're talking about between 2 and 2.5, I think there was a min there, right? Adjust our y's a little bit more, maybe from negative 5 to 5. There are some situations, and we'll talk about why, that you will need to find the locations of these maxes and these mins. Okay? Let me introduce you to second calc min and second calc max. Okay? You go back to this one. To find a min, it says left bound. You're going to go to your min, and you're going to go to the left of your min and press enter. This creates an arrow or a line saying, okay, I'm going to look to the right of that line. It then says right bound. You go to the right of your min, press enter. That way it knows it's looking between those two. You will then have them guess, and they will find your min. There are some situations where we will need to find a min because it's going to be quicker and more efficient to find the answers. Same thing for a max. You'll just go to left, go to the right, boom. Reasons why we're going to do that, because most of the questions that you'll see, these calculated questions, involve function analysis. When is my original function increasing or decreasing? When does it have a max? When does it have points of inflection? Et cetera, et cetera, et cetera. When is it concave up? And we need to review Unit 3. It's good review for your midterm. You will find that proportionally there are more problems from Unit 3 than any other unit for your midterm, and you will see that on your practice midterm. Okay? Something is increasing when its values are going up, right? What calculus thing can tell us when something is going up? Yep. What about the derivative? Yes. Something is increasing when its derivative is positive. Positive is greater than 0. We talk about f. Well, we've done things where f prime is positive. That means f is going up. That's how it works. It's not f prime is increasing. It's f is increasing when f prime is positive. If f double prime is positive, well, that's telling me f prime is going up. F double prime is positive tells me something else as well about f. Okay, so something is decreasing when its derivative is negative. If f prime is negative, f is going down. If f double prime is negative, f prime is going down. Something has a relative max when we change from going up to going down. That's when the derivative will change from positive to negative. F prime will have a relative max if f prime goes up and down. F prime will go up and down if f double prime changes from positive to negative. Positive values on a derivative means the original function's going up. Something will have a relative min if it goes down then up. It'll go down and up when its derivative is negative and positive. What typically separates negatives from positives? Or positives from negatives? The x-axis or zeros. But we understand it could be zeros or it could be undefined. We could have jumps, we could have asymptotes. Those are when signs could change. Something is concave up when its second derivative is positive. If the second derivative is positive, the original function I know is concave up. Concave down when its second derivative is negative. Now, it's concave up. This is what it looks like to be concave up. You will find that's when f prime is going up. F prime is going up when f double prime is positive. So we can either say, oh, if f prime is increasing, if the slopes of the tangents to f prime are positive, f double prime is positive. We see f prime values go from very negative, less negative, 0, positive, more positive. Those values are increasing. F is concave down, f double prime is negative. That's the same as saying when f prime is decreasing. You can see my values are positive, less positive, 0, negative, more negative. Okay, this is all a review of Unit 4. We have a point of inflection when f double prime changes sign. That will be when f prime changes direction. If f prime changes from increasing to decreasing, we'll have a point of inflection. If f prime changes from decreasing to increasing, we'll have a point of inflection. All of these things we need to remember. Okay? All right, let's get into some of these function analysis problems. Here's f prime. When does x, for what value of x does f attain a relative max? This is what we have to do. We have to first say, okay, f is going to be at a max if f goes up, then down. You need to translate that to what we have. We have information about f prime. Well, that's when f prime changes from positive to negative. You will then be able to graph f prime. You will be able to adjust your window to be from -1 to 9. You will be able to see or find when this crosses the x-axis from positive values to negative values. You need to be able to find the intersections by graphing y equals 0. So let's go ahead and graph this. If you have an older operating system, make sure you use parentheses. Not needed for the bottom because it's the square root. And it already includes it. Making sure you adjust your window from -1 to 9. I'm going to keep my y's as -5 to 5. I think it'll be fine. And this is great. These are negative values. These are positive values. When do we change signs from positive values to negative values? Right here. F prime goes from positives to negatives, which means F is going to be increasing to decreasing right there. Don't assume this is at 1. Second calc intersect. It might end up being at 1. Enter, enter, enter. Ends up not being at 1. It's 0.920. F prime changes sign from positive to negative. Okay? That's the easiest one. They gave you F prime. You just had to look at signs. Let's skip a couple examples and go to this one. Here is F prime When is F concave up? You need to think about F is concave up when F double prime is positive. You have the graph of F prime. There's two things you can think of. You can either think of F double prime is positive if F prime is increasing, or F double prime is positive if the slopes of F prime are positive. So, thinking about it that way, we can easily see our answers. There's another way to do it, but it's not as important as this more efficient way. We can graph x squared plus 1 times sine of 3x minus 1. We're going from negative 1.5 to 1.5. Oh, what did I do? There we go. F double prime is positive when F prime is increasing, or when the slopes of the tangents of F prime are positive. We're talking about this interval is when F prime is increasing or when the slopes of the tangents of F prime are positive. To be able to find this interval, all you need to do is find the location of this min and the location of this max, and it's in between those. So I'm not going to find zeros. Instead, I'm going to go second calc min to the left, enter to the right, enter, guess, enter, negative 0.240, and then I'm going to go and find the max. Second calc, max, to the left, enter, oops. Second calc, max, to the left, enter, to the right, enter. Keep this. And I get 0.964. Okay, these are the things you'll be seeing on your homework. Make sure you do your homework in preparation for the quiz.